Okay, and so I know that last video was a lot there to remember, alright, but here's the key points. The key points are that exponential growth functions, power functions where my coefficient's positive and my power is positive, and logarithmic functions where my base is greater than 1. I'm saying to you that all of those things, as x approaches infinity, those functions approach infinity. And so we want to know which one grows the fastest and which one grows the slowest. And so I ranked them. I said exponential functions of the form a to the x, where a is greater than 1, are the fastest. And then from there, I went power functions of a certain form and then logarithmic functions of a certain form. Okay, and so in terms of computing a limit, where you have one of those functions divided by another one of those functions, as x approaches infinity, how do we determine that limit? Alright, and so what I'm saying to you is that if the function in the numerator is approaching infinity faster than the one in the denominator, I know that that limit's infinity. However, if the denominator is approaching infinity faster than the one in the numerator, I know that that limit's 0. And so now we're going to apply these ideas to these limits here. So looking at the first one, what I know is that I see that both the numerator and denominator are both going to infinity as x approaches infinity. And so if you recall, I get that this is infinity over infinity, which from a while back I told you was an indeterminate form. And so just looking at this, I do not know what the limit is. All right, I need to do some sort of algebraic manipulation, or I need to pull out some calculus type of ideas here. And so what do we notice about the numerator? Well, I said that I know that it goes to infinity because the numerator is a power function. Whereas in the denominator, I have a logarithmic function. I have the natural log of x. And so if it's hard for you to picture the top one being a power function, what you can do is you can just rewrite it so that it looks like x to the 1/4, and then this is ln of x. Okay, and so looking at above here, which one dominates? Is it the power function or the logarithmic function? Well, the power function dominates as x approaches infinity because that one is going to infinity faster, right, than the logarithmic function. So here, I'm going to say that since what's in the numerator is going to infinity faster than what's in the denominator, then we know that that limit is going to be infinity. And so here, I'm going to note x to the 1/4 approaches infinity faster than x approaches infinity. So the limit as x approaches infinity equals infinity, since the numerator approaches infinity faster. Okay, so the key idea there is that I know both of those functions are approaching infinity as x approaches infinity, so I get this indeterminate form infinity over infinity. So what do I need to do? Well, I need to look at them and be like, okay, well, I know that in the numerator is a power function and the denominator is a logarithmic. I know that power functions dominate as x approaches infinity compared to logarithmic functions. And since the power function's in the numerator, I know that that limit's going to be infinity.